Hello everyone, let's continue our course. In these sections, we will discuss the dedicated barrier procedures. First, let's talk about the EPS barrier. In the EPS, barrier are the basic QoS control unit. A EPS barrier is used to transmit all the services flow associated with the same QoS policies between a UE and a PGW. All the services flow transmitted on the same EPS barrier are subject to the same data transmission treatment. Here, in these pictures, we can see our end-to-end services between the UE and the Internet. And actually, end-to-end services actually is connections between the UE and the Internet. These connections doesn't terminate in the eUtran. Also doesn't terminate in the EPC. Only the Internet terminate these end-to-end services. And these end-to-end services include the EPS barrier and the external barriers. EPS barrier actually is in the part of the EPC, terminated by the EPC. And the EPS barrier almost the same with the eRAP. Actually, eRAP is a connection between the UE and the SGWs, terminated by the SGW. But right now, the SGW and the PGW, usually we put these two devices together. So actually, there's no difference between the EPS barrier and the eRAP. eRAP here include the radial barrier and the S1 barrier. And the radial barrier actually is between the UE and the eNodeB. Here, radial barrier indicate a group of radial resource. Here, for the radial barrier, we have two types of radial barrier. One for the signaling, another for the data. So we call it SRB, signaling radial barrier, and DRB, data radial barrier. Let's discuss the EPS barrier. The EPS barrier actually is a connection between the UE and the PGW, same like the eRAP. The EPS barrier are divided into default barrier and the dedicated barrier. In the EPS, the default barrier is set up and remains established throughout lifetime of the PDN connections in order to provide the UE with always-on IP connectivity to that PDN. Which means the default barrier actually means a default IP connections between the UE and the PGW, as long as UE connected with the PGW. UE will get an IP address from the PGW. Once UE get this IP address, we will keep our IP connections between the UE and the PGW. And these IP connections, we consider it as a default barrier. Other EPS barriers routing to the same PDN are known as the dedicated barrier. Dedicated barrier can be set up or modified only upon the request of MME. And all the barrier level QoS parameters are assigned by the EPC. Once we set up the default EPS barrier between the UE and this PGW, if we set up the second barrier between the UE and the same PGW, this second barrier we will call it dedicated barrier. And the dedicated barrier can be set up or modified only upon the request of the core network. Here, this picture shows the QoS architectures in the EPS. We have many QoS information and the parameters here. QCI, ARP, GBR, MBR, and the AMBR. All of these, they are the QoS parameters. QCI here means QoS class indicator, because all the services, they have different QoS requirements and the QoS parameters. But we divide all of these services into 9 different classes. Each class we use an indicator indicated, and we call it QoS class indicator. And the ARP, which means allocation and the retention priorities. GBR here means guaranteed bitrate. MBR here means maximum bitrate. AMBR means aggregation maximum bitrate. And this is the architectures for those QoS parameters. This QCI, including the barrier rate, delay time, and packet losses. All of this is based on the QCI. Different QCI will have different barrier rate, delay time, and loss rate. For the barrier rate, we also have guaranteed bit rate and the non-guaranteed bit rate. Some services, they have GBR. Some services, they are non-GBR. And also maximum bit rate and aggregation maximum bit rate. For the QCI, please see these tables. This table shows the details of the QCI. For the QCI value range is from 1 to 9. In total, we have 9 different QoS classes. Each EPS barrier is defined with a QCI. The QCI determines how an IP packet on a barrier is processed on the user place. For example, different QCI, they will have different priorities. Here, the highest priorities is the QCI 5, and the QCI 1 has the second priorities. Different services will belong to different QCI, and also different QCI will have different priorities. Here, from QCI 1 to the QCI 4, they are the GBR services. From the QCI 5 to the QCI 9, they are the non-GBR services. So, which means usually the services belong to the QCI 1, 2, 3, 4. They are the real-time services. The services belong to the 5, 6, 7, 8, 9. They are the non-real-time services. And the different services belong to different class. They will have different time delay budget and different packet error loss rate. Here, from the table, we can see that the QCI 1 has the highest requirement for the time delay because the QCI 1 is the VoIP services, voice. The voice services also, of course, has the highest requirement for the time delay. And for the QCI 9, default barrier. And this default barrier usually is used for the data connection, data services, PS data services. They has the lowest requirement for the time delay. Vice versa for the error rate. For the voice services, QCI 1 has the lowest requirement for the error rate. Here, the error rate is 10 power minus 2, which means send 100 packet, only 1 packet has error. But for the QCI 9 data services, the error rate should be 10 power minus 6. 1 million packet we sent, only 1 packet has the error. This is a very high requirement for the error rate. For the ARP is another QoS parameters. ARP here means allocation, retention, priorities. These priorities is used for the user. We set these priorities on the HLR. Different user, they will have different priorities. The ARP of a barrier is used to decide whether the request barrier can be established or modified, and whether such a request is rejected when the network resources are limited. When we have enough resource, we can accept more and more users as possible. But if our resource is limited, then we will accept the user who have the higher priority. Here, the following IE are related with ARP priority level, used for this decision to ensure that the request of the barrier with the higher priority level is preferred. Here, the ARP also is used for the preemptions procedures. Preemptions procedures actually is one of the procedures of the core admission control. Core admission control is used for the access the user. When user want to access to the network, if the network doesn't have enough resource, usually those user will be rejected by the network. They cannot build a connection with the network. They will be rejected. But If this user has the higher priorities, for example, the ARP value of this user is very high, higher priorities, we can let this user preempt the other user, which means we will release the resource of some other low priority user, and the freed resource will be allocated to those high priority users. And these actions we call preemptions. Here, the preemption capabilities define whether a barrier with lower ARP priority level should be dropped to free up the required resource. Here, the preemption vulnerabilities here define whether a barrier is applicable for such dropping by a preemption capable barrier with a higher ARP priority value. This is another QoS parameters, GBR and the non-GBR. For the GBR barrier, for a GBR barrier, a fixed amount of bandwidth resource is preserved, regardless of whether the resources are used or not. For the non-GBR barrier, for a non-GBR barrier, no fixed amount of bandwidth resource is preserved, and therefore traffic is not ensured. Here, the default barrier is only the non-GBR services. And for the GBR barrier, only belong to the dedicated barrier. For the QoS subscriptions, usually is subscribed by the EPS system. QoS is subscribed in the HS and the PCRF. HS here for the default barrier. Actually, HS is the name of the HRR. In 2G and 3G, we call it HRR, but in 4G, we call it HSS. HS for default barrier, PCRF for dedicated barrier. PCRF is a new device for us, for the EPC. Here, PCRF here means policy charging rule functions. The setup and the modification of a dedicated barrier both can be initiated by a UE or a IMME only when a UE is in connected mode. That is to say, a eNodeB cannot actively initiate this process. If the QoS of the default EPS barrier cannot meet the services requirement, the UE can initiate the dedicated barrier setup process. The release of the dedicated barrier, this process can be initiated by a eNodeB or a MME only when a UE is in the connected mode. Please look at here, and this is the signaling flow for the dedicated EPS barrier setup. So we can see these pictures. Many devices involved here: UE, eNodeB, MME, SW, PGW, and PCRF. Here, because the QoS information is subscribed in the PCRF, so PCRF will send the QoS parameters to the PGW, and the PGW will forward QoS information to the SW, then to the MME. MME will forward the QoS information of the dedicated barrier to the eNodeB through this message, eRAP setup request message. eRAP setup request message, this message includes the QoS informations of the dedicated barrier and sent to the eNodeB. Once eNodeB receives this message, eNodeB will allocate the radio response, a radio resource correspondingly. And eNodeB will use this message, RC connection reconfiguration, send this message to the UE, set up the DRB. Here, because we already set up the DRB1 for the default barrier, so here in this case, we will set up the DRB2 for the dedicated barrier. Once the radio resource allocation is finished, the UE will send the RC connection reconfiguration complete message to the eNodeB. And the eNodeB will reply the eRAP setup response message to the MME. Once the MME receives this response message, which means the dedicated barrier setup is finished in the EUTRAN network. And then, at last, the MME will send the response to the SW, SW will send the response to the PGW. and the PGW will send this ACK to the PCRF. And this is all the procedures for the dedicated EPS barrier setup. Here, it mentioned the resource assignment is triggered by the UE because UE actually initiate the dedicated barrier setup procedures. UE want to set up a dedicated barrier, trigger resource assignment procedures. And here, this part actually is for active the dedicated barriers. This is the works for the corner work. The corner work, as we can see here, corner work initiate the active the dedicated barrier procedures. And for the dedicated barrier release procedures, is initiated by the network. Maybe initiated by the MME, maybe initiated by the eNode B. Here, this is the signaling. Here, in these examples, MME send the eRAP release command to the eNode B. Then, eNode B start to release the radio resource for the UE. These two messages is used for release the radio resource. Okay. After we release the radio resource, eNode B will send eRAP release response message to the MME. And the MME will send delete barrier response to the UGW. Here, this UGW indicate the SW and the PGW because we combined SW and the PGW into one hardware. And this new hardware we call UGW. Here, U means universals. Let's have a summaries for these chapters. First, we discussed the default barriers and the dedicated barriers. Then we discussed the architectures of the QoS. We discussed many parameters of the QoS, including the ARP, the QCI, the GBR, and the AMBR. Also, we discussed the dedicated barrier setup procedures and the dedicated barrier release procedures. That's all for these chapters. Thanks for watching.